Hello students, my name is Professor Muhammad Asim and we are doing AdMath. AdMath for IGCSE students which have syllabus code 0606 and for CIE O level students which have syllabus code 4037. So both kind of students can get equal benefit from this course. Students, in last lecture we did question number 6 exercise 16.1 from chapter number 16. Name is kinematics and the topic of this exercise is applications of differentiation in kinematics. Today we are going to do some more questions from this exercise, but before I start question number 7, I would suggest all those students who are watching my lecture first time, kindly go to my playlist. There is a folder name is AdMath. Watch previous lectures of this chapter, then you will have good command on this topic. Let's start question number 7 part A. A particle moving in a straight line passing through a fixed point O, its velocity v meters per second t seconds after passing through O is given by v is equals to cos 3t plus sine 3t. Find the value of t when the particle is first instantaneously at rest. Students, whenever the particle is instantaneously at rest, it means that its velocity is 0. So just replace v by 0 is equals to cos 3t plus sine 3t. Then shift cos 3t over there. So minus cos 3t is equals to sine 3t. It can be right minus 1 into cos 3t is equals to sine 3t. Or it can be right minus 1 is equals to sine 3t upon cos 3t. Or sine upon cos is tan, therefore sine 3t upon cos 3t is tan 3t. And then 3t is equals to tan inverse minus 1. And if you use your scientific calculator and find the value of tan inverse 1, you will have 3 pi by 4. 3 cancel by 3, then the answer of t is pi by 4. So when the particle is instantaneously at rest, the value of t is pi by 4 seconds. So very easy part. Move to part B. Find the acceleration of the particle when t is equals to pi. So v is equals to cos 3t plus sine 3t. You know how to find the acceleration? Differentiate the velocity with respect to time. So dv by dt. Cos 3t derivative is minus 3 sine 3t. And sine 3t derivative is 3 cos 3t. So A at t is equals to pi. So minus 3 sine 3t is pi plus 3 cos 3t is pi. So A is equals to sine 3 pi is 0, 0 into minus 3 is 0 plus 3 cos 3 pi. If you find the value of cos 3 pi from your calculator, you will get minus 1. So A is equals to 3 ones are minus 3 ms minus 2. This is the SI unit, meters per second square. So this is the question number 7. Very easy and very important according to examination point of view. Move to question number 8. Question number 8 is a particle starts from rest and moves in a straight line so that t seconds after leaving a fixed point O, its displacement s meters is given by s is equals to 2 minus 2 cos 2t. Part A, find an expression for the velocity and the acceleration of the particle in terms of t. Very easy. Differentiate this displacement by t. You will get velocity. Derivative of 2 is 0. Minus 2. Derivative of cos 2t is minus 2 sin 2t. Minus minus plus 4 sin 2t ms minus 1 meters per second square. This is the answer of velocity, and differentiate with respect to time of this velocity, you will get acceleration. So 4 sin 2t derivative is 2 cos 2t, 4 to the 8 cos 2t ms minus 2 meters per second square is the answer of acceleration. 8 cos 2t acceleration and 4 sin 2t is velocity. So this is part A. Now part B is find the time when the particle first come to rest and its distance from O at this distance. Very nice, very easy, very important part. Find the time when the particle first come to rest. First come to rest means its velocity is 0. So v is equals to 4 sin 2t so replace v by 0. 4 sin 2t, 4 divided by 0 is 0 is equals to sin 2t, or 2t is equals to sine inverse 0. And if you use your scientific calculator, sine inverse 0 is pi, but your calculator must be in radian mode, hence t is equals to pi by 2. T is equals to pi by 2. So find the time when the particle first come to rest. The time is pi by 2 seconds and its distance from O at this instance. Very easy. So distance equation is s is equals to 2 minus 2 cos 2t. So s is equals to 2 minus 2 cos 2t. T we have find pi by 2. So s is equals to 2 minus 2 cancel by 2 cos pi. Cos pi is minus 1. Minus 2 into minus 1 is plus 2. 2 plus 2 is 4 meter. So this is the answer of complete answer of part B. So very easy question and very important. All questions of this exercise are very important. Now move to question number 9. Question number 9. A particle moves in a straight line such that its displacement s meters from a fixed point O on the line at time t second is given by s is equals to 50 e minus 2t minus e minus 4t. Part A. Find the time when the particle is instantaneously at rest. So first we have to find the velocity, because the time when the particle is instantaneously at rest, the velocity is 0. The velocity is not given, but the displacement is given. So first differentiate this displacement by t. So ds by dt is equals to 50 e power minus 2t derivative is minus 2 e power minus 2t, and e power minus 4t is minus 4 e power minus 4t, so minus minus plus e power minus 4t. This is the velocity. Now, because we need the time when the particle is instantaneously at rest, so we should write ds by dt velocity is equals to 0. So 0 is equals to 50 into minus 2e minus 2t plus e power minus 40. 50 divided by 0 is equals to minus 2e minus 2t plus e power minus 40. Taking minus 2e minus 2t is common. It is, or you can write, the more easy way is shift this minus 2 e power minus 2t over here, so it is e power minus 40. 2 is equals to e power minus 40 divided by e power minus 2t. E power minus 40 divided by e power minus 2t is minus 4 plus 2 is e power minus 2t. Taking ln on both sides, ln 2 is equals to ln e power minus 2t. So ln 2 is equals to ln and e cancel, it is minus 2t. Kindly wait. I am just checking. Is there any mistake or not? Minus 2 e power minus 2t plus e power minus 4t, no mistake. 2 e power minus 2t, no mistake, is equals to e power minus 4t. E power minus 2t is divided, so minus 4t plus 2t is minus 2t. Taking ln on both sides, so it is ln and e cancel, minus 2t is equals to ln 2. Kindly wait, I am checking. Yes, I found the mistake. I forgot to write the derivative of this e power minus 40. The derivative of minus 40 is minus minus plus 4 plus 4 plus 4 and plus 4 and 2 upon 4, and then I am Sorry, this was a very silly mistake, but what can I do? Sometime it happens. So 2 upon 4, 2 ones are 2, 2 twos are 4, 1 upon 2 is equals to e power minus 2t. So taking ln on both sides, ln 1 upon 2 is equals to ln e power minus 2t. ln and e cancel, minus 2t. Or you can write ln of minus 1 upon 2, ln 1 upon 2 is equals to t. Or you can write ln 1 upon 2 to the power minus 1 upon 2 is equals to t. This is the property of logarithm. Ln 1 power minus 1 upon 2 is 1, and 2 power minus 1 upon 2 is equals to t, and t is equals to ln. This 2 power minus 1 upon 2 becomes 2 power plus 1 upon 2, and finally you can write t is equals to 1 upon 2 ln 2. This is the final answer, the answer of your book. So hope you completely understand this question. It was very easy, but I forgot to put 4. Now move to part B of this question. What is part B? Find the displacement of the particle from O when t is equals to 2. Very easy question. Part B. What was our equation given in the question? S is equals to 50 e power minus 2t minus e power minus 4t. You can see again, 50 e power minus 2t minus e power minus 4t. So we have to find the displacement when t is equals to 2. So just put 2 in this equation, you will get the final answer. S is equals to 50 e power minus 2, t is 2, minus e power minus 4, t is 2. S is equals to 50 e power minus 4 minus e power minus 8, and use your scientific calculator, directly put 50 e power minus 4 minus e power minus 8. You will get the final answer. I am calculating. The final answer is 0.899 meter. This is the answer of part B. Part C. Part C is, I am copying part C over here. Because it is very important part. Read this. Find the total distance traveled during the first 2 seconds of its motion. First 2 seconds. So how to find the distance, total distance, first 2 seconds? First we have to draw the diagram. See carefully. T is equals to, at this point T is equals to 0. At this point T is equals to half ln2. At this point T is equals to 2. So we have to find the distance from this point so T is equals to, at T is equals to 2. Students, what this distance? S is equals to 0.899 meter of part B. This is the distance 0.899 meters at T is equals to 2. Now we have to find the distance of T is equals to 1 upon 2 ln2 as well. What was our distance formula? S is equals to 50 e power minus 2t minus e power minus 4t. So at T is equals to 1 upon 2 ln2, which is 0.347, sorry. So S is equals to 50 e power minus 2 into 0.347 minus e power minus 4 into 0.347, and calculate this distance. You will get the value 12.5 meter. 12.5 meter. So at this value, this is from 0 to T is equals to 1 upon 2 ln2. The distance is 12.5 meters. Hence, total distance is 12.5 plus 12.5 minus 0.899. Use your calculator to find the final answer, which is 24.1 meter. So kindly do practice of this part, the total distance. So whenever you find the total distance, you must draw this diagram. This is very important. So students, this is our today's class, where we did 3 questions of exercise 16.1, question number 7, 8 and 9, and question number 7 is the most important question, and especially this part. Okay, what next? Only 2 questions are left. Definitely we will finish the whole exercise 16.1 in next lecture. So do practice, and if you have any problem, write in comment box. I will help you. I will describe each and every part which you feel difficult. And kindly do subscribe my channel, and whenever you subscribe, don't forget to press the bell icon button, so that when I upload my videos you will get the notification. Kindly share my videos as many as you can. Okay students, good luck for next lecture.